In the present video, we're going to continue talking about algebra using the software Maxima. And the specific topic for this video is first degree equations in one variable. So we're going to start by opening up this Maxima worksheet. A few definitions. What's an equality? An expression where two algebraic expressions are the same. An equation will be an equality where there is an unknown value, which unknowns are typically represented with x, y, z, and so on. An identity would be an equality that is satisfied for all possible values included. And in an equation, we distinguish between the left-hand side and the right-hand side. And as a matter of fact, Maxima has functions called LHS for left-hand side and RHS for right-hand side that are used to separate the elements, those elements in an equation. Here's the line referring to that. Let's consider this equation, x cubed minus 3x equals 5 minus x squared, and we're going to separate the left-hand side and the right-hand side. You have access to the worksheet where these exercises are presented, and so you could just simply click on any part of the line there and do shift enter, and then we have EQ is that equation. The left hand side is x cubed minus 3x and the right hand side is 5 minus x cubed. Now we can produce a new equation based on the previous equation by doing the left hand side minus the right hand side. This is just basically what we do like when we move all the elements to one side by hand. The degree of an equation is the exponent of the highest power of a particular unknown. For in this case is the first order, and this is what we're going to be dealing with. This is an equation EQ is equal to 7x minus 6 equal to x minus 1. Now what I'm going to do here is to subtract 3x from both the right hand side and the left hand side and add 6. Okay, the idea here is to isolate the x in the left hand side. So out of this EQ, I'm going to make EQ1 equal to the left-hand side minus 3x plus 6 equal to the right-hand side minus 3x plus 6. Adding and subtracting the same numbers in both sides do not change the equality, the equation. So we're going to do Control-Shift, and we end up with 4x equals 5. And so we divide by 4, and we end up with x equals 5/4. That is the solution to the original equation 7x minus 6 equals 3x minus 1. Here's the same example handled in a slightly different manner. EQ, right? Now we replace EQ with EQ minus right hand side. When we do that, both sides are subtracted. We're going to add 5 to eliminate the independent term on the left hand side and divide by 4 to get our solution. Now that's not the only way to solve equations. And the first order equations are relatively simple to solve. But Maxima has a function called solve, in which you're going to provide the equation and the unknown, and it will try to give you all the solutions possible. In this case, there's only one solution, 5/4, which is the same one that we determined earlier on. The solve function in Maxima is very useful, as you can tell. And it can be used to solve not only the first order, but any order equation. Here's the second order equation, solved for x, and then the solutions come out in symbolic form as a fraction with square roots. If we use float, you can get the solutions in decimal format. Here's the third order equation, solved, and also obtain the float values. Now, there are equations where there is letters besides the unknown, like this one, that it will solve for x. It turns out to be a ratio of sums of variables. Here's a case that commonly used in hydraulics is the velocity of an open channel, where Cu is a constant and it's the Manning's coefficient has to do with the line of a channel. S0 is the slope of the channel. R is called hydraulic radius. The hydraulic radius is equal to area over perimeter. So we substitute that into the equation MEQ. We get this result. Now for a rectangular channel, a bed with B and depth Y, the area is given by B times Y, and the weather perimeter, which is the part of the cross-section in contact with water is equal to b plus 2y. And so we do the substitution of those two terms into the last version of MEQ, and we get a more complex equation. Let's try to solve for S0, and they ask you are those terms, well, they're all positive, so we do shift enter, and it gives me an expression for S0. Can we solve MEQ, which is this one, for y? Well, it tries to solve for y, but y shows up in both sides of the equation, so it's not really a solution. What we could do, however, is that if you notice the terms that involve y in here are raised to the 2/3, to the 2/3. So what if we raise everything to the cube? If we do that, and so replace MEQ by MEQ cubed, then we get y squared here and we get y squared here. So it's sort of a quadratic equation. And we try to solve it from here, and we do find expressions where y is explicitly written in terms of the other terms. It's quite complicated, but there's an expression right there. And basically these terms are the same. One is positive, one is negative, because that's what happens typically when you have a quadratic equation. Word problems can be used to transform into algebraic problems. For example, I paid $3,250 for a computer, a printer, and a fancy mouse. The computer costs $1,800 more than the printer, and the mouse costs a quarter the cost of the printer. What are the prices of the three devices? If X represents the cost of the computer, then the cost of the printer is $1,800 less than that of the computer, so Y will be equal to X minus 1,800. And Z, the cost of the mouse, is 1/4 of the cost of the printer, but we know that the cost of the printer Y is equal to X minus 1,800, and so we have this expression for Z, the cost of the mouse. Now we know that the sum of all of them is equal to 350. Now if we substitute y equal x minus 1800 and z equal to 1/4 of x minus 1800, the values that we determine from here, into EQ, let me actually press here to create EQ, replace, and then we end up an equation that depends on x alone. We're just going to expand the quantity, and I'm going to use solve here. And it turns out that x is equal to 2,444.44, and we can calculate the cost of the other devices like that. And if we add them together, we get that there's a rounding up happening because I actually chopped off the result here. Yeah, it had to be chopped up like that, so there's an error. That's called numerical error, but we did get the right results. And so this is what I had to show about first order equations, and in this way we finish this video on first degree equations in one variable.